Welcome to the tutorial on finding meaning in data. This tutorial will discuss the different ways journalists can find a story within a data set and the different mathematical tools journalists often use to do so. Once you have gathered data that is relevant to your story, you will need to analyze that data to determine where the story lies, whether the information is accurate, and how to interpret the data for your readers. It will often take time to sort through all of the data you have collected in order to find the trends in the data, as well as the exceptions to those trends, and investigate what they all mean. There are a number of mathematical tools journalists can use to help them accomplish this task, and fortunately, none of them are too complicated. In particular, we are going to look at 7 different mathematical tools journalists use frequently in order to analyze the data they have collected. Those tools include averages, medians, percent changes, rates per unit, margins of error, rounding, and how to write with numbers. We will start with averages, which are known as means in the field of mathematics. A mean is the middle value of the sum of all the values you are given. To calculate the mean, you will add up all the numbers in the data set you are analyzing. Then you will divide that sum by the number of values that are contained in the data set. For example, if you are given the numbers 10, 14, 17, 31, and 34, then you would start by adding all of those numbers together. Once you do that, you will see that the sum is 106. Since there are 5 values that were added together to get that sum, you would then find the average by dividing the sum of 106 by 5. The result, of course, is 21.2, which is the mean of this data set. In contrast to the mean is the median, which is similar, so be sure to pay close attention to this slide in order to determine the difference between these two mathematical formulas. The median is the number that appears in the middle of a data set when the data set is arranged in order from the lowest number to the highest number. For example, if we were to look at the same data set as we did a moment ago and organize all the numbers in ascending order, then we would have 10, 14, 17, 31, and 34 as our data set. The number in the middle of that well-organized data set is 17, so that is our median. However, if we had an even number of variables in our data set, then we would have to take the mean of the 2 variables in the middle of the data set in order to find the median. So for example, if we had one additional number in our data set that was 39, then we would have 2 numbers in the middle of that set, both 17 and 31. In order to find the median, we would have to find the mean of 17 and 31. Since 17 plus 31 is 48, and 48 divided by 2 is 24, 24 would be the median in the second data set. You will often see the term median used in reference to income because a much larger number of people earn low incomes instead of high incomes. And despite the low number of people earning high incomes, that data toward the higher end would skew the average if it were calculated. So the median is a more accurate representation of the middle amount people earn, especially given the amount of numbers you're dealing with when you look at a large data set. The next mathematical formula we will look at is percent change. This is extremely useful for showing growth or decline in an area, such as crime statistics and population sizes. The percent change can be calculated by taking the difference between the ending value and the beginning value, and then dividing that difference by the beginning value. Finally, you multiply the number by 100 to turn it into a percentage. So for example, if you had a town with a population of 14,011, in 2013, and you wanted to analyze the percent by which the population increased in 2014 when the total population went up to 15,753, Then you would start by finding the difference between 14,011 and 15,753. That difference is 1,742. You would then take that difference and divide it by the beginning value, which in this case is the population from 2013, which is 14,011. Therefore, 1,742 divided by 1411 equals 0.12433. Now, in order to turn this number into a percent, you need to multiply it by 100. When that's done, you get your final result, which is that the population of the town increased by 12.43% during the year. If your percent change formula ever gives you a negative number, then that means there was a decrease instead of an increase. Be sure to report this information to your readers. You can state it as a decrease of 12.43%, but do not state it as an increase of negative 12.43%, because that would be mathematically inaccurate. Another thing to consider when you deal with percent change is the perception your use of that formula conveys to your readers. If used incorrectly, the percent change data can make it sound like dramatic differences occurred, when really the change was minimal. For example, if a town's population doubles, then it sounds like there has been a huge increase in the number of people residing there. However, if you later discover that there was only one person living in the town to begin with, then you realize that having one more person move to the town is not such a big shift. Therefore, it will always be important to make sure that your use of data regarding percent change accurately portrays the information you are reporting and does not skew your readers' impressions of the data against a valid perception. The next mathematical tool journalists find themselves using frequently is rate per unit. This can be used to ensure that people's perceptions of data are not skewed by a description of the percent of change. Rates per unit are most often used when reporting crime and medical statistics, such as when journalists report how many people within a certain size population are impacted by a particular crime or medical condition, although the formula can also be used for other calculations, of course. To determine the rate per unit, you first must determine the rate at which something occurs. For example, if there are 402 violent crimes in Brooklyn, then there is a total population, if there are 402 violent crimes in Brooklyn, New York in a year, and there is a total population of 2,566,000 in that borough, then the rate of violent crimes is 402 divided by 2.566 million, which is 0.0001566. To then determine how many people that percent is out of, let's say, 100,000 people, you will just multiply the percentage by the unit you are using as your base, in this case 100,000. So 0.0001566 times 100,000 is 15.66, and that means that there are nearly 16 victims of violent crimes per every 100,000 people in Brooklyn. Now, on another note, when it comes to polls, it is extremely important for journalists to know about margins of error. Margins of error reflect the number of percentage points the reported data may be off by. Since a poll cannot cover everyone's potential vote, it is a bit of an estimation and could be off by a few percentage points. Consequently, there is actually a range of possible percentage points being reported in poll data. Therefore, it is imperative that you always report the margin of error when you state the results of a poll. That way, your readers will know how close the results really are, and you will know where the true story lies. For example, if a pre-election poll reports that candidate A has 54% of the votes and candidate B has 46% of the votes, then it might not look like too close of a race. However, when you take into consideration the fact that the polling margin of error is 3 percentage points, you start to realize that the race is extremely close. That's because candidate A now has a range of potential votes from 51% to 57%, and candidate B now has a range of potential votes from 43% to 49%. When you see candidate B could earn up to 49% of the votes, and candidate A could earn only 51% of the votes, you see that the race is actually quite tight. So, if you ever see a large margin of error, you need to be on the lookout because you should be extremely skeptical of the results of that particular poll, since it means the data being reported has a huge range of potentially accurate results, and it's hard to determine where within that range the true values will fall. If you are ever reporting large numbers, then you will likely want to round them so that they are easy to report and so that your readers can quickly understand the basic size of the numbers you are reporting. To do this accurately, you will want to round anything less than a 5 down and anything higher than a 5 up. For example, the number 69,456,897 should be rounded because it's so large and difficult for people to conceptualize or say. And in this case, the number should be rounded down to more than 69 million because the digit right after the 69 is a 4. Now, finally, it is important to know how to report numbers in accordance with the AP Style Guide. Writing with numbers can be tricky, but there are a few basic rules you can follow to help you articulate the numerical data effectively to your readers. First, if you are writing about specific numbers that have been rounded, then write more than or fewer than when describing those numbers. Second, if you are writing about a small number of individuals or individual items that have been rounded down, then use the word fewer. However, if you are writing about a small number of items that act as a group or come in bulk form and have been rounded down, then use the word less. Third, if percentages are hard for your readers to conceptualize in a story, then consider using fractions to help your readers effectively understand the data you are reporting. Sometimes a statistic like 69% can be difficult for people to understand, but a fraction like 2/3 can be easy for the audience to visualize in their mind's eye. Those are some of the ways that journalists can use simple mathematics to find meaning in the data they have collected. Moving forward, try to force yourself to analyze the data you have gathered in different ways to detect patterns in it. With time and practice, you will get used to doing these mathematical operations, and they really will become an automatic part of your routine as a journalist. Thank you so much for listening, and good luck analyzing your data sets.